Hello inquisitive brains, we are back with another video. In this video, we shall know about optical fiber. So let's start. An optical fiber is a dielectric waveguide. It is made up of glass or plastic. It contains a core region and a cladding. The outer jacket provides protection and mechanical strength. The electromagnetic waves can be confined in the core region and transmitted by total internal reflection at the core cladding boundary. Plastic fiber cables are used in optical transmission because of their low cost, high source fiber coupling efficiency and ease of handling. Their attenuation is high and restricts their application to short links. Glass fiber cables consists of a glass fiber clad with a sheet of different glass. The fiberglass is made up of pure silica, and silica has lowest transmission loss. To vary the refractive index, silica is doped with the oxides of germanium, aluminium, titanium and phosphorus. Now, fiber needs protection against excessive mechanical strain. Thus, fibers are normally given a plastic primary coating then a nylon coating. The core diameter of optical fiber usually ranges from a few micrometers to a few 10 of micrometers, and the outer cladding diameter from 100 to 200 micrometers. Optical fiber communication system. Fiber optics communication is the science of transmitting data, voice and images by the passage of light through thin, transparent fibers. In contrast to wire transmission, in which an electric current flows through a copper conductor, in optical fiber transmission, an electromagnetic field propagates through a wire that is made of a non-conducting material. Because of its immunity, low cost and lightweight, optical fiber is becoming the medium of choice for fixed, high-speed digital telecommunication links. Optical fiber cables are supplanting copper wire cables in both long-distance applications such as feeder and trunk portions of telephone and cable television loops, short-distance applications such as local area networks for computers and home distribution of telephones, television and data services. In 1966, electrical engineers K.C. Cow and G.A. Hockham, working in England, suggested using fibers for telecommunications. In April 1977, the first practical optical communication system was introduced to carry telephone calls over 13 km between British Telecom's Malt Helsham Research Laboratories and Ipswich. An optical fiber communication link consists of the following elements: an electro-optical transmitter, which converts analog or digital information into a modulated beam of light; a light-carrying fiber which spans the transmission path; and an optoelectronic receiver which converts detected light into an electric current. For long-distance links greater than 90 km, regenerative repeaters are usually required to offset the attenuation of signal power. To understand optical fiber communication, it is necessary to know how a source at the transmitting end generates optical power, how this power travels down the fiber, and how electrons are used to connect the power at the receiving end. Therefore, it is important to know about light propagation. The propagation of light through an optical cable can be explained using ray theory. Ray physics suggests that when light passes from optically denser to rarer medium, light bends away from the normal. As the angle of incidence becomes more oblique, the refracted ray is bent more until finally it leaves at an angle of 90 degrees with respect to the normal and just grazes along the surface. The angle is called critical angle. When the angle of incidence exceeds the critical angle, light reflects back in same denser medium. This phenomenon is called total internal reflection. To achieve this, a cladding of fiber with a low refractive index is added transverse section of cladded optical fiber. So this was all about optical fiber in brief. You can like the video and you can subscribe my channel. Further, you can comment me for making more such interesting videos. Thanks.